So I remounted the loudspeaker with this new Wago clamps. It is not connected yet, but it will be in future. And then the receive signal from the DCF receiver, it is green wire, goes to the front, goes to the oscilloscope. For some reason, it's a very erratical signal. I don't know why. It suddenly appears. It has been stable for the whole day, but now there's something wrong. And I can't find out why, but we will find out. Well, then I took my reference system. If I look at the LED, it produces the same erratical behavior. So I don't know what's wrong. Maybe if the weather conditions that we do not receive well, let's find out. So we will take this, because I'm living in an apartment with a lot of concrete walls, maybe that's the problem. First we will go out through the hall. It's dark now. We go to the living room and we go onto look, here is very okay. So I turn around. I'm now 90 degrees, of course it will not receive. Well, the signal is quite strong. I now go back to the hall. I go back to my man cave. Still working here. Just at a meter, go back, 2 meters from the position where I'm working, there's a distortion. Probably it's the weather, or whatever. You see it flickering as my oscilloscope shows strange signals. So we have to find a way how we can enhance the signal to get here in this room. So I'm just curious if it helps if I ground the radio receiver to my, this ground. Well, it's a big mess on my desk, but it doesn't matter. Connected it. I want you viewers to be part of my experience. I'm just wondering if I plug it in anywhere on the system, in the ground. I have to take off my spectacles. Where's the ground? It's the black one. The battery is this. And I put it in there. Struggling. Yeah, it has no effect. You never know. I think mathematical or science students will say that it's a stupid experiment because they know why it should work or not. But that's not a solution. We will try something else. Then I have another idea. I have a wire that's going to the room, the window. It's just a coaxial, the white one. It's coming out here. Maybe if I connect the inner of the outer mantle to the ground or whatever, any connection on the system, that the red LED will receive a better signal. Let's try out. So I connected a wire to this Wago clamp. And I'll take me this one from the inch. It's connected to the ground of this receiver. It's still flickering. I now connect it to so. The result is No result, no difference, it's still flickering. But it's now 11 o'clock in the evening and the signals are almost normal. There is a difference in the length of the signal. It's not always 100 or 200 milliseconds. So the reception is going better, I think. If I look at my reference, so it's still erratically, but if I move it a little bit to the right, here, it's still a little bit erratical, but almost normally. So I think it has to do with the rain and the clouds that go away, and then reflection or whatever. Radio experts can tell you all about this, that it will be. They can explain it. But there's something else I want to tell you. I did some experiments, but now the outgoing DCF signal is going to my oscilloscope, but I also connected it to the input of my microcontroller that is used to decode the time signals. You can see here it's now about 3 volt, but that is because in the software you can see I commented it out, but now here the input port on the microcontroller is configured as float, and you can configure it as pull up. If you configure it as float, it's free, it has no up or down or pull up or pull down. If you configure it as pull up, then there's a 50k to 100k resistor connecting it to the VCC of 3.3 volt. But as I found out after 6 or 8 hours chatting with ChatGPT, STM8S forums, if you configure it as float, input float with no pull-up, then the interrupt behavior is very undefined. It keeps generating interrupts. So to have a stable software behavior, you have to use pull-up. So we will do that now. To be clear, you now see the program running that has no pull-up on the microcontroller input of this DCF signal. I've prepared everything, I compiled it to use the pull-up, and if I press the run button, this one, we'll go to the scope, and I will press the now. You can see what is happening. The pull-up is 50 to 100k. It's that strong, or you can say the DCF receiver signal is that weak, it cannot pull the signal to ground. The signal is here, but it should go to ground. But if we use this principle, the software will not run well. So how do we solve this problem? The signal, the green one, coming from the DCF receiver is too weak to pull the signal low enough for the microcontroller to detect it as a low. So what do we use as an interface? I think about a transistor or a MOSFET. I'm not experienced with SMD MOSFETs, but I just bought me someone, I think from China or whatever. It is the BSS138 that is suitable for the 3.3 volt power supply to enhance and invert the signal. So I asked ChatGPT, is this a good choice? He said yes. So we are going to use this one. So I then created me this system. This is the MOSFET, is an SMD component, and I soldered a few wires to it. The 3.3 volts plus should be connected here. Maybe I can turn it around, you see it better. And then it goes through a 4K7 ohm resistor to the drain, I think it's called. And the source is this one, has to go connected to ground, and this is the gate, like the base of a transistor. And I will use this unit. Well, I don't think it's that nice because it's so floating in the air, but anyway, see it as a creative object. I will go to implement it here between this receiving signal and the entrance into the microcontroller. I mounted my MOSFET amplifier, or whatever you want to know it, to call it, between the output of the DCF77 receiver and the input of the microcontroller. The signal goes to the gate. I'm using this new Chinese connectors, this one, instead of those Wago ones, for experiment, just to see how it behaves. So this is the DC, the signal coming from the receiver. It's going to the gate, or the base of a transistor, or the gate, here, on this little piece. And the source should be connected to the ground. The power supply, the VCC, the orange, coming from the microcontroller, is going to the corresponding pin, and there's a resistor of 4K7 between the power and the return signal, the third one, which then goes back. It's difficult to see, but there's a green wire that goes to the input of the DCF microcontroller decoder. For now, I did not connect my oscilloscope input, this wire, to the system, so I will do that first. Meanwhile, I put my reference apparatus near, I power it on, but it takes a little time before it is integrated. Well, it's flickering, I don't understand now. Well, I don't see any signal on my oscilloscope. So we will first connect oscilloscope probe directly to the output of the DCF77 receiver to see what's going on. I now experience there is a difference between the Wago and the Chinese clamp. The Wago clamps you can probe inside here to see the signal, but with the China clamps you can't. Analyzing the circuitry, I can put this, that's my oscilloscope connection, on the middle of this Wago connection, the receiver, and I see on my oscilloscope correct or incorrect signals, but anyway there are signals to be seen. But if I connect this green line from the oscilloscope to the output of the gate at this point, I look at my oscilloscope, nothing is happening. The reason that nothing was happening was because there was a signal only about 0.4 volt high, because I had soldered the FET just the other way around. So I made me a new one, glued in some plastic wires, used this new China clamps for experiment. You could have all kinds of solutions to do this. We have here the schematic. The pull-up resistor is placed here on the board between the 3 volt and the other signal that goes to the red one of the MOSFET. And then one time I maybe had some big short or whatever, my microcontroller was defective. I measured 80 ohm between the 3.3 volt and port PA1, which I use. So I measured this. I took me another one as a reference. This is the defective one, 80 ohms. Normally it should be 350K or so. So I had another one which was okay, only it doesn't, the TX error for the serial port is defective, but we don't use it now. But anyway, it works. And you can see there's a 100 millisecond signal and sometimes the 200 millisecond signal. And why I'm using this MOSFET, now the signal is inverted. So you have to look at the low signal. Maybe that microcontroller was also not that good. I exchanged it with a new one. If I look at my oscilloscope, it is now 3.1 or 2 volts. So that's very nice. I also changed my interfaces. Yeah, I only used 2 pins to clamp them, but I created me a new system. My debugger is complaining. And you can see on the underside I use 4. It's much more stable. You can do anything. There is this special beeper output on the microcontroller. This is the microcontroller board with pins equal the pins of the microcontroller with something inside here. So PD4 is the beeper output. As you can see, I connected the beeper with this new China clamp to the beeper output with a resistor of 1K. So now I will start. The reception is going on. Now I will start the program. And you can hear the detection of the low pitch 0 byte and the high pitch 1 byte perfectly. But now we are going to try to decode the 0 and 1 bytes into information. But that will be in the next video. Thanks for watching.